Hi everyone, Dr. Ron Bio here again to discuss karyotypes and what they mean, specifically in the context of meiosis and genetics. So let's get started here and take a look at a human karyotype. A karyotype is a complete representation of an organism's genome. Okay, it's a complete collection of genes. So here we're showing the human karyotype with a 2n of 46. That means that there are a total 46 chromosomes in a diploid cell. So I've labeled all of those chromosomes 1 through 46 to show you what I mean here. Chromosome 1, for example, has a gene right here and a gene right here for chromosome number 2. Chromosome number 3 has a gene right here. Chromosome number 4 has that same gene there. So 1 all the way through 46. Another way of saying this is to say that there are two sets of 23 chromosomes, one from each parent. One from the male, and we can see here that this set shown in blue, labeled with the male symbol and numbered, was delivered in a haploid sperm. So that sperm contained 23 chromosomes, a chromosome number 1, a chromosome number 2, all the way up through 23. Yet another way of saying this, showing this, is that the human karyotype also, for a diploid, is composed of the female set. So here that you see the female's representation, contribution of to the karyotype. So females contribute chromosome 1, chromosome 2, chromosome 3, all the way up through 23, just like the male did, to give you that total of 46. Again, 23 plus 23. Okay, so yet another way of showing this human karyotype, the 2n of 46, is to show you that there are 23 pairs of homologous chromosomes. Keep in mind, a homologous chromosome is the same chromosome. It's the same size, and it has the same genes at the same locus, right? So for this locus right here, you have a gene. Also, on this homologous chromosome number 1, you would have a gene at the same locus, okay? So you have a pair of homologous chromosome number 1s, a pair of homologous chromosome number 2s, all the way up through chromosome number 23. Because there are 2 in a pair, and there are 23 pairs, again, you get that 2n of 46 shown there. So keep in mind how we got here. We're going to review this again, even though we showed the male and the female contribution. The human gametes are used in fertilization, are the sperm and the egg. The male sperm has an N of 23, which is the number of chromosomes in a set. The female egg has an N of 23, which is the number of chromosomes in a set. And when they fuse together during fertilization, you create a zygote that has 2 sets with an N of 23. So that gives you a total of 46 chromosomes, okay? Let's take a look at a few examples here for practice. In this first example, the organism has a 2N of 16. What would a karyotype for this diploid organism look like? Well, let's break it down by first showing the male and the female's contributions. Okay, so here you can see that the male for a 2n of 16 contributes 8 unique chromosomes. So that's chromosome 1, chromosome 2, chromosome 3, chromosome 4, chromosome 5, 6, 7, and 8. The male packages one of each into a sperm with an N of 8. The female will also package that same number of chromosomes, 1 through 8, into her egg. So when fertilization occurs, the 2 sets come together, N plus N, in this case, equals 16. That's because 8 plus 8 equals 16. So you get a 2N of 16 here when you bring all these chromosomes together. Okay? From this, you can determine a lot about an organism. So looking at a karyotype can be used for a lot of activities. I use a karyotype in my classroom to teach genetics. So for my students tuning into this, we have done the same thing for other organisms here. using a karyotype to look at specific genes, right? So if we look at this right here, what is that genotype? We look at this gene right here, what is that genotype? Okay, so it's very useful to understand what a karyotype is, how it represents the haploid gamete contributions of both males and females on their way to becoming a diploid zygote, okay? So I hope this helps you understand organisms a little better. I hope it gives you a better idea of meiosis and of genetics. Let me know what you think below, and we'll see you next time.